Hey everyone, it's Brent, and due to the request of Jackson and Chase specifically, I'm going to be going over maybe a few problems, probably a few problems on the angle projectile worksheet that we had been working on throughout the week, just so that we're all a little bit more prepared for the test tomorrow. Now, first and foremost, we're going to be going over number one, considering that was the one that gave us the most trouble in the first place and caused us to all go into a panic for the weekend afterward. So, we're going to go after that one first, and hopefully this recording goes well because it's the third time I'm recording this because I had to clear more space for the entire video anyways. So here we go. Now I'll be switching between my notes as well as Mr. Dolson's notes because Mr. Dolson's answer key is incredibly helpful, and I want to be sure that my work always does align with his, even though I've checked probably 100 times already, but it never hurts to be safe. So let's start. A lovesick lad wants to throw a bag of candy and love notes into the window of his girlfriend's bedroom 10 meters above. So let's draw that picture out already, okay? Sorry, I have it set to eraser. So I like to always picture it as a triangle since it helps for future calculations that I'm going to have to do with SOHCAHTOA when it comes to problems like this. Mr. Dolson usually likes to do it. I forget how he likes to draw it, but he kind of draws it weird. But for me, I always do just a regular triangle. You can feel free to draw a different picture if you'd like, but that's how I usually do it. So 10 meters above. That already gives us one of our variables. So let's try and get an early start on the X and Y chart here, which is incredibly helpful. So a of X, unless stated otherwise, remember this, unless stated otherwise, is always going to be 0. Okay? There's our first free 0, as Mr. Dolson mentioned in class today. And then a of Y is always going to be negative 9.8. Then, since again, it gives us one of our variables here, we can assume that, not assume, we know that delta y is 10 meters. Delta x is what we're going to be trying to find, as we find out as we read the question further here. Assuming it just reaches the window, he throws the love gifts at 60 degrees to the ground. That gives us another piece of information right here, 60 degrees. And it just reaches the window. Now, whenever it says something like this, that means if I were to draw this out a little differently, that means the parabola stops right at the peak. Imagine this is the dude right here, whatever that works, and he's throwing, the gift all the way up there. This is the windowsill, and it stops right there, stops right here. At the peak of a parabola, the initial the final velocity is always going to be 0, okay? Because when you reach the peak of a parabola, you instantaneously stop at 0 for just a split second before you go and start your final velocity all the way down. Now, if that doesn't make sense, that's okay. Just always remember that in a question like this, where it explicitly states it just reaches a point and it's going upwards, always remember, final velocity for v is always going to be 0, okay? That's probably the reason why none of us were able to solve it the first time around. It's because we didn't realize that when it comes to a problem like this, when the parabola is cut in half essentially like this, and the point is stopped at the middle of the parabola, at the peak of the parabola, at the top, vy is always going to be 0. Again, sorry if I'm talking a little bit in confusing terms. You can just ignore me if you want, and just remember that Vy is always 0 when it comes to a problem like this, okay? I want to try and make this as simple as possible for everyone. So if you just want to remember that, if you see a problem similar to this one on the test, if you just want to just remember Vy is 0, that's cool with me. You don't really need to remember y. So we have these variables so far, and for a, we're trying to find out the velocity that he should throw the bag. This is a typo. It should be he. At what velocity he should throw the bag, which means we're trying to find the initial v for the hypotenuse right here. And we also need to find out how far from the house he is standing when he throws the bag, which means we are trying to find delta x, which we already have highlighted by a question mark right here. So before anything else, let's finish up our x and y chart. Initial velocity for x, we do not know either. And then the initial velocity for y, we are going to find out, but do not know either right now. And the initial velocity for x, we do not know either. I mean, the final velocity for x, we do not know. And then we have time right here to find out. So, first and foremost, let's find at what velocity did she throw the bag at, okay? Now, since currently we have 3 variables thus far, we are able to find initial v for y. So, we can find it by utilizing the third equation in our list of equations. You know, the ones he always puts on the board, etc., etc. And the one that we would use here is v squared is equal to v naught squared. Remember, in regards to this problem specifically, since we're trying to find initial v for y, this is v naught y in this case, plus 2a delta y. Now plug in your variables. V of y is 0, so 0 squared equals v naught y squared plus 2 negative 9.8 10. Now you should end up with, when you solve it out a little bit, 0 equals v naught y squared minus 196. Add on both sides, 196 to v naught y squared, square root both sides, and you should end up with a pretty little number of v naught y equals 14. I'll pause here for a moment so you can get to work, and if you need to rewind the video in case you don't quite understand the concept or how we got to this answer, since I'm going to be needing to erase this work, sadly, since I do not have nearly enough space to fit all of it on here. So just gonna put it that there. And now we're going to move on. Okay, sorry. It might take me a bit to erase stuff. Okay, so now we have 4 variables for y. However, most importantly, we have initial v for y, which is 14. So that means we know this part of the triangle, which is 14. Now, take a look at here. Since we have a degree and we have one of the side lengths, we can use SOHCAHTOA. That was terrible. Hold on a minute. There we go. SOHCAHTOA. So, since we have the opposite of the angle and we have an angle, we can use SOHCAHTOA. Since we're trying to find this line right here, this one right here, trying to find the initial velocity of that line right there, since it's asking us in A, at what velocity should he throw the bag, and this tells us what velocity he'll be throwing the bag at, we use SO, because that is sine 60, but most importantly, the opposite, which is 14, over the hypotenuse, which we'll use x here to represent. So multiply x on both sides. Sine 60 equals 14. Sine of x divided by sine of 60 on both sides. That's terrible. That's really bad. But yeah, you get the idea. Divide by sine of 60 on both sides. And be sure to make sure your calculator is in degree mode. right? I forgot to put it into degree mode earlier today, and I was incredibly confused when we were doing the practice problems until I realized that I had it in the wrong mode. So remember, put it into degree mode. And after you do this, you should get that x is equal to 16.2 meters per second. And now we have our first answer for A, which is 16.2. Now, again, I'll give you some time to look at the work before we move on and to rewind the video if you need to sort of go over a concept that you might not understand. And then we'll be moving on to solving for delta x. All right. All right. Now, let's move on to delta x. Now, since we have all four of these variables right here, we are now able to solve for time. So let's solve for time, shall we? You can use really any of the equations, but honestly, for simplicity's sake, I'm going to use the first equation, which just so happens to be v equals v naught plus at. So plug in your variables. V for y is 0, v naught for y is 14, plus negative 9.8, and then t, which you're solving for. Subtract 14 on both sides. Negative 14 is equal to negative 9.8t. Divide by negative 9.8 on both sides. And now t should equal 1.42. Not should, it will. Don't worry, it will. Just gonna shorten this eraser a bit. Okay, now that's too small. There we go, much better. Now we have time. 1.42. Erase that again. Now we have time. Should be able to now solve for this, right? We should be able to solve for delta x, right? Not quite. You still need one more of these variables in order to be able to use any of the equations from the list of three equations that we have given to us by Mr. Dolson. Now, this is where we use SOHCAHTOA once again, because again, we have 16.2 for the hypotenuse, and we have 14 for the y, for the height of the triangle. Yeah, for the height of the triangle, let's say. So now we can find the initial velocity for x. That's what we're going to be solving for. Now, again, doesn't necessarily matter, I don't think, as long as you use one of the ones that have, adjacent in them, for simplicity's sake, and due to the fact that Mr. Dolson used it on his answer key, we're going to be using ka in order to find the adjacent side. So, cosine 60 is equal to adjacent over hypotenuse, which we'll represent by using x for now. And we know that the hypotenuse is 16.2. Multiply by 16.2 on both sides. Again, making sure your calculator is in the right mode. And you should get for x 8.1 meters per second. In fact, I'll double check right now on Mr. Dolson's sheet, wherein he has the same work as well right here. And yes, he ends up with 8.1 meters per second as well for the initial velocity of delta x. So now we have this. So we can now put here 8.1. Now we're able to solve for delta x using the middle equation, which is delta x is equal to initial velocity times time plus 1/2 a, which is 0, times acceleration. Sorry, the 0 is acceleration. So 1/2 times a, which is 0, times t squared. And that doesn't matter because it would end up being 0. So you just end up doing 8.1 times 1.42 for delta x. And that should end up being, if I'll double check on my calculator just to make sure, times 1.42, 11.5. And what do we have right here as our answer? 11.5 meters. Hopefully that helps to shed a bit of light on how to solve problems like these, which are way more larger scale than some of the other problems we'll be doing. And I hope that cleared up some of that confusion. Again, if you have any specific questions, you can always just message me on Snapchat or something, or if you have my phone number. I'm probably going to be awake for a while since I've got other tests I need to study for as well. So I'll be basically here all night to answer questions and stuff like that for this particular problem if you need me to. It's still a pretty beastly problem for our standards anyways. So even though I'm able to do it kind of handily, it's still definitely something I get tripped over as well. So it's definitely one you need to be careful on, and definitely one where really drawing out your XY charts and your triangle really does help to illustrate the problem. So, like I said, we'll be going over one or two more. And again, if you have any specific questions or would like me to walk through it again for you individually, message me on Snapchat, text me, message me on Instagram. Does not matter. I'll probably be here for a while, so I have got all the time in the world. And as you can see, same exact work here, 11.5. Now then, I think I'll pass on doing number 2. We did an example like that sort of in class, and the in-class one actually was more complicated than number 2. So I think we might be okay with that. Let's go over this one. Why not? Number 3. Simple enough. It should be a good representation of what the easier versions of these kind of questions should be on the test. So, a bullet is fired at an angle of 60 degrees. Let's get our triangle started up right now. 60 degrees. Initial velocity up. There's our hypotenuse already. Initial velocity of 200 meters per second. That's our hypotenuse. You can already probably tell where this is going. What is the maximum height reached by the bullet? This is easy, really, because this is really dependent on SOHCAHTOA, as many of these, I believe, will be. Let's see if we're I don't care. So, remember, a of x, unless stated otherwise, is always going to be 0. A of y is always going to be negative 9.8. The initial v of x and the initial v for y can both be solved by using SOHCAHTOA once again. So, let's find the initial v for y first. Since we have since we have the hypotenuse and the degree, we can use sine. Sorry, I don't know why I was having a stroke there. Sine. So sine of 60 equals opposite, which we'll use as x right here, over our hypotenuse, which is 200. And you should get x equals 100 here. No, sorry, 173.2 is what you should be getting for that one here. As you can see, 173.2, 200 sine of 60, as we're doing right here, since you're multiplying by 200 on both sides. So yes, 172. Sorry, 173.2 should be what x is, which is your initial velocity for y, which is 173.2. And now, using the same sort of idea, we can find the other side length. Since it's the adjacent, we can use the ka, so cosine of 60, which is equal to the adjacent, which we use as a here, over the hypotenuse, which is 200. So do the same thing. Multiply by 200 on both sides. And you should get for the A, otherwise known as the initial V for X, 100 meters per second. Now, let's take the time to write out the rest of our variables, even if we don't end up using them, just because it's good habit to be able to do that. Delta X, which is not what we're trying to find, is a question mark. And delta Y, what we're trying to find, is also a question mark. And we know that due to the fact that it stops at a peak once more, since it says what is the maximum height, we stop at 0 for the final velocity of y. And now for the final velocity of x, it is also 0. Now, we can simply use the last equation to solve for delta y. Like, we didn't even really need this. We just needed this, honestly. So, we can use the last equation, which is v squared, which is in this case is vy squared, which is equal to initial v of y squared plus 2 acceleration and delta y. Since that's what we're trying to find. Now we plug in our variables. V squared is 0, which is equal to 173.2 squared plus 2, negative 9.8 delta y. And if you solve that, you should get, I think you guys can handle, going through that. You guys are smart people. I'm sure I'm not going to waste your time going through the steps to do that. You should end up getting, though, for delta y and our answer for maximum height, 1,530 meters.